Kia ora, Year 13. I'm going to start going through some of the external exam questions for the probability concepts and probability distributions papers. So this is last year's probability concepts exam, and I'm just going to start on question 1, part 1. This covers a lot of the big things that we talked about when we did the probability concepts topic. It's got conditional probability, no trees, it's got Venn diagrams, tables, relative risk, and testing for independence. So if you pause the video and have a go at the questions first and then work through it with me, you can put it on double speed if you want, because I'm going to go quite slowly. One of the things I want to focus on in here is using the correct notation for conditional probability and for joint or and probabilities. So this question is all about a South Island high school, and the first part is about 2 option subjects that were chosen by Year 10 students. And the option subject choices of 167 of them were as follows. So we're given 3 facts. This should be screaming at you, go and do a table, right? Because I've got 2 variables. I've got a technology subject and I've got a language subject. And the first question, just skimming it first, is what proportion of students at this high school hadn't chosen a technology subject but were studying a language. So I guess they implicitly mean Year 10s. Don't get hung up about that, right? So we're going to use a table for that one. And then we're asked about 3 individual students being chosen from that group of 167 Year 10s. And then the school is making a claim about the link between choosing a technology subject and selecting a language subject. And we have to investigate the validity of this claim. So make sure when you're answering that you give a final statement on whether you think their claim is valid or not valid. And when it says use statistical reasoning to support your answer, that means do some maths. Okay, let's go back to the start. So I'm going to whack this into a table, and the table's just going to have 4 boxes. We'll do language here, no language here, technology subject here, no technology subject here. So 62 had chosen to do a technology subject, that's going to go down here. 138 had chosen not to do a language, so that can go here. In total there are 167. And 10 had chosen a technology subject and a language. So they go in there, and now we can quickly fill up the rest of the boxes. So we'll get 52 in here. This column down here will be 105. 52 and what gives me 138, gives me 86 in this cell of the table. Lastly, this number here must be, let's see, 167. Take away 138, gives me 29 here, which gives me 19 here. Obviously, there are other ways, other orders that you could have got there. Right, so we need to say probably that they had not chosen a technology subject, but they were studying a language. So I'm going to write that like this, language and not technology. Now just notice that I'm choosing from all of the students in this Year 10 cohort. So the bottom number, the denominator in the fraction, is going to be 167. And the numerator is students who hadn't chosen a technology subject, but were studying a language. So it's these 19 here. So we get 19 out of 167. And if I round that to 3dp, I get 0.114. And that, not surprisingly, is an achieved question. Right, now the next one, I'm going to use that table. So I'll just get rid of the mess here a wee bit. Let's see. Oh, magic. Okay. Right, so with this next one, we've got 3 individual students who were chosen at random from the group of 167 Year 10s. Given that all 3 were studying a technology subject, figure out the probability that all 3 were not studying a language. So if you just think first of all about the first of those students, what we're interested in is we know that they were studying a technology subject. So this is a conditional probability. I'm only interested in the ones who were doing tech, which means I'm just interested in having 62 names in my frequently used probability hat, right? So the bottom number here is going to be 62. And we want to know what's the probability that student was not taking a language. So for the first student, it's going to be 52 out of 62. But we've got all 3 of them in the same boat. The thing to watch out for here is that the number of students left is going to drop by 1 each time. So the probability that all 3 were not doing a language, given that they were doing technology, you can think of, if you want to think about it as being on a big tree, you can. You probably don't need to think about it like that, though. So the first student, we had 52 names in the hat who were doing were not doing a language, right? So 52 out of 62 were not doing a language. Right, once that first student's been picked, we know that there are only 61 names left in the hat, and 51 of those names are not doing a language. And for the third student, there are only 60 names left in the hat, and there are 50 of those who are not doing a language. And when we times all those together, we get 0.584, and I've rounded that to 3 significant figures. Okay, so that's a merit question. You just need to watch out in level 3 for whether you need to think about with or without replacement. Okay, let's look now at the next question. Oh, why did I erase that? That was silly. Never mind. Too late now. Okay, the school claims that if a student selects a technology subject, a Year 10 student, this has no effect on the probability of them also selecting a language subject. So this should scream independence test at you, right? We have to investigate the validity of this claim and use statistical reasoning to support your answer. So I'm going to do this question in 2 different ways. We can either do a direct independence test, but the more intuitive way to do it is just to say, well, let's look at, let's turn that off. Okay, I don't know why that happened. First of all, let's look at the conditional probability. Given that a student takes a technology subject, what is the probability that that student also takes a language? And then we're going to look at the probability if they don't take a technology subject. What are the chances that they take a language? So by comparing these 2 conditional probabilities, we can evaluate the school's claim, right? Because if there is no effect on the probability, then those 2 conditional probabilities should be exactly the same. The other way, and that's a nice way to think about what the independence test is doing, right? So that's the first thing we're going to do. And we had our table. We'll just put the table back in up here. So the table looked like this: 10, 19, 52, and 86. And this was T, and this was L. All right, so the probability that they take a language, given that they take technology, is going to be, out of 62 students, 10 of them take a language, right? And here, given that they don't take technology, we're going to have 105 students and 19 of them take a language. Let's just have a look at where those numbers are coming from. So the technology number is here. This is the 62 number, right? And this is my first conditional probability. So I'm just looking at students who take technology. In the second one, I'm asking how many students don't take technology. So it's 105 here, and 19 of them do take a language. Now, when you work this out, for this one, you get 0.161, and for this one, you get 0.181. Don't be tempted to say that those 2 numbers are pretty close, so it's basically the same. If you look at this to this, there's a bit of a difference there, right? It's 0.02, which looks like a small number, but if we compare that to 0.161, we don't get 0, so we get about, what's it going to be? It's going to be about 12 percentage points different. So what am I going to say based on those 2 conditional probabilities? I'm going to write this out over here because I'm a bit sick of marking work where there's not enough clear communication of what you find, right? So the first thing to say is these probabilities are not the same, or they are different. Then the second thing to say is what it means. So students who don't choose tech are more likely to take a language. So let's say that. Okay, so students, or you could say it the other way around, students who don't take a tech, we better put it properly, don't take a tech subject are more likely to take a language. So I'm sure some of you are forwarding through this part, but this is really important that you write it out properly. And the last thing that we've got to say is, what is the school's assumption? Is it right or wrong? Okay, so the school's assumption, or the school's claim, I think they said assumption here, is wrong. So that's the first way to do this question, and that's an excellence question here, by the way. It's not a merit question, even though it's buried halfway through. The second way to do this is to do the independence test, and this is usually quite poorly done, so I'm going to go through this one very slowly as well. Right, so we're going to use the table of numbers, and we're going to look at two separate probabilities and then compare them. The probability that someone takes tech is equal to 62 out of 167. The probability that someone takes a language is equal to 29 out of 167. We're going to times those two probabilities together, and we're going to see what we get. We get 0.064 to 3 significant figures. Now we're going to compare that to the probability of having both of those things happen, taking tech and taking a language. And there are 10 students who do that out of 167. So that's equal to 0.060 to 3 significant figures. So I'm going to 3 significant figures because that's kind of the convention with what we do in probability calculations. I don't particularly like this exam question. I think that they've made it that those numbers are pretty close together. But I would still say here that these probabilities, so the first thing I'd say, are different. The second thing I'd say is that this means that the events choose a language and choose a tech subject are not independent. And lastly, I'd explain what do we mean by it not being independent. And that means if I know someone has chosen a tech subject, it affects the probability that they have chosen a language, and the other way around, or you can just write and vice versa. And the last thing we've got to say here is what we said before. The school's claim is invalid. So if you're watching this and you're in my class, please make sure that you are confident with this independence test, because in the end of topic test, it was some very, very easy marks that were just chucked away by lots of you. It's not a difficult calculation. We just have to follow through the steps, right? So going over it one more time, because I've got a minute before the video runs out, I work out my two separate probabilities, and then I times them together. And if two events are independent, that'll be the same as having the probability of both things happening. Right, so I'm going to show you why that happens now. Oh, no, I'm not actually. I've only got 1 minute. I'll save that for another video. So I haven't got completely finished this question. The next bit that I've got to do is part D and then part E. So I'll do a follow-up video in a few minutes on that one. Thanks for watching. Let me know if you've got any questions.